Good afternoon. Welcome back. Today we're going to be finding areas between curves using calculus, if that wasn't already clear to you, and specifically the technique of integration. So I have 3 problems to get through. They all involve 2 curves and finding the area between them. So the area is going to be bound by both curves, and the left and right bounds are found just naturally, or sometimes you have to find them on your own. So the first area we're going to find is the area between y equals 2x, y equals x squared minus 4x, and the left and right bounds are going to be x equals 0 and x equals 6. And this problem in the book that I found, where I found this, gave you the graph. So I will give you the graph just like the book did. So y equals 2x, that's just a straight line that goes to the origin with a slope of 2. And let's make that a little longer. So that's y equals 2x. And the other function is a parabola with, well, let's verify this. So this parabola will have 2 x-intercepts. One will be at 0 and one will be at 4, and it's a right side up parabola. So it'll go through the origin, and the x-axis at 4. Okay, that's why I should have made the straight line longer. Okay, so we know we're going for this area, and we know that we're going to integrate where the y equals 2x is the upper function. So 2x minus the lower function. And all I need now is to know the bounds, left-right bounds, which were given to us by the problem. So I can just copy the 0 here and the 6 here, and then find the antiderivative. But I need to simplify this function first to make finding the antiderivative a little easier. So distributing the negative, that'll be negative x squared plus 6x dx. Okay, now I can find the antiderivative. Negative 1/3 x cubed plus 3x squared from 0 to 6. Plugging 6 in, 6 cubed is 216, so negative 216 over 3. And 3 times 36 is 108. When I plug 0 in, I just get a bunch of zeros, so this is all I have to simplify. And that'll be 108, not 109, over 3. I guess I'll change the mixed number. It's nice to know, get an idea of what the area is. So that'll be 30. Oh, that goes in perfectly. So that's 36. Let me double check that, because usually these areas don't end up whole numbers, and this one did, so I'm a little suspicious. That's right. That's right. That's right. Nope. I think that's good. So we got an area of 36. All right, the next one we're going to do is y equals x, y equals x squared, and you are not given the left and right bounds. So we're going to have to find that on our own. At least we know what these look like. This is a straight line going through the origin with a slope of 1, and this is a parabola. So we're going for this area, and we know that the upper function is the line, so x minus x squared dx. Now I need to know the bounds. So to know these 2 points of intersection, I just set the 2 functions equal to each other. X equals x squared, 0 equals x squared minus x, 0 equals x times x minus 1, so 0 and 1. So the intersection points are 0, 0, and 1, 1. Okay, now we can find the antiderivative. And then evaluate from 0 to 1. That's 1/2 minus 1/3. And that I can do in my head is 1/6. So we got an area of 1/6, a tiny area. And I'm also going to throw in one that has some trig in it. So we can practice our derivatives of trig functions by finding the area between y equals cosine x, y equals secant squared x, from negative pi over 4 to pi over 4. Okay, so let's see what this looks like. Cosine x, well, it's a sinusoid with a max of 1 and a min of negative 1. At 0 it's 1, so it goes like this, comes back up, full cycle at 2 pi, so halfway is pi, and this is pi over 2. Might as well put this is 3 pi over 2. And since we're going from negative pi over 4 to pi over 4, I'm going to draw what it looks like on this side as well. That's pretty much all I need. That's a terrible graph, but I don't need that part. Okay, so this is negative pi over 2, which makes this negative pi over 4, and this pi over 4. Okay, I don't know yet which graph is the upper one and which one's the lower one, until I'll know that when I figure out what this looks like. Okay, so if you remember from your trig, the secant curve has asymptotes. And remember, the secant is the reciprocal of cosine. So at 0, cosine is 1, and so is secant. So I know I have a common point here. At pi over 2, cosine is 0 and secant is undefined. So this is an asymptote. And at negative pi over 2, same deal, asymptote. And if you remember from your trig, secant goes like this, it alternates like that. So the part that I'm interested in is the part that is tangent to the cosine curve here and approaches infinity at the 2 asymptotes, pi over 4. Oh, sorry, I put the asymptotes in the wrong place. They should have been here. Let me redraw that. Oh, I just realized, no, everything was fine. I should have just left it. So the asymptotes are here. There was actually nothing wrong with my curve. But the area that we're going to calculate doesn't extend to the asymptotes. We only want to know this area. The area between the curves. From negative pi over 4 to pi over 4. And I have a choice here. So I could either integrate from negative pi over 4 to pi over 4, do it in one piece, or I could go from 0 to pi over 4, find that area and then multiply it by 2, because this area is symmetrical around the y-axis. And I like working with 0, so that's what I'm going to do. So we're going to go from 0 to pi over 4, and we'll multiply everything by 2 at the end. The upper function is the secant squared one, and the lower function is cosine. Okay, now I do my antiderivative. Don't forget the 2. Antiderivative of secant squared is tangent. Antiderivative of cosine is sine. I'm evaluating from 0 to pi over 4. Don't forget the 2. Tangent of pi over 4 is 1. Tangent of, sine of pi over 4 is rad 2 over 2. And when I put 0 here, I get 0, and when I put 0 here, I also get 0. So that's good news. All I have to do is this. 2 minus rad 2, and that is it. Rad 2 is about 1.4, so 2 minus 1.4, so we got an area of about 0.6, which makes sense because that is small. So I would expect a small area. Okay, so don't forget, you got to know what the graphs look like, so you know which graph is the upper bound and which one's the lower bound of the area. And then if they don't give you the left and right bounds, like we had to do for the second one, then you need to do some algebra to find the left and right bounds on your own. Then do your antiderivative, plug in carefully, make sure your answer makes sense. If it's a small area, make sure you get a small answer, and you're good to go. Okay, thanks for watching K19 Math. See you later.